Hello everyone. So today I'm going to show you how I put side dots or position markers in the neck, and I can't help myself. I'm mostly going to talk about a bunch of stuff I tried and set aside, or some interesting kind of detours on this. First of all, when guitars were first made, as I understand it, there weren't any position markers. And so this would have been in maybe 1850 in Spain in the shop of Torres and others. I don't think they use position markers. And when they are used on classical guitars, typically there's maybe just one marker at the 7th fret or 5th fret. I'm not sure exactly. It's not my area of expertise. But in guitars and banjos and mandolins, the markers have been many more than one, usually. And it's interesting to note that in older instruments, sometimes the markers ended up on unusual frets. I used to work on a lot of turn-of-the-century banjos when I was first getting started in instrument making. And I was very entertained to see that sometimes you would find a banjo with markers on fret 10 and 13, say. Just not quite sure what the thinking was. Of course, on a guitar where the neck joins the body at the 12th fret, we don't need a marker at the 12th fret. It's perfectly clear where that is. But as necks got longer and guitar bodies got shorter, it seemed like people needed some orientation. And sometimes it kind of even went maybe a little bit too far. I know that on a lot of Gibson guitars, they mark not only the 3rd fret, but also the 1st fret. It seems like the 1st fret probably doesn't need to get marked either, but I guess that was just for sense of balance visually, particularly considering that a lot of those markers were not only on the edge, but also on the face of the fingerboard. Now, I don't really like the markers on the face of the fingerboard. I think the fingerboard is better left alone. Just my opinion. A couple of times I have been called upon to do something a little different, but left to my own devices, which I hope normally to be, here's what I end up doing on my own guitars, which is, 3, 5, 7, 9, then the octave, and then again repeating those same intervals on the 2nd octave. You'll see that I position the dots on this side of center, and this is just my way of doing something a little different, I guess. But it more represents where you actually place your finger than where the center of the fret spacing is, and I thought it made a little bit more sense. I don't think it really matters, but it's just the way I do it, and I like it. Before we go ahead and put some dots in this neck, let me just talk a little bit about some of the things that I've tried and played around with over the years. Well, we'll start with this. So the whole idea of having a decoration on a musical instrument made out of either shell, seashell, like this one is made of mother of pearl. And then sometimes there's another variety of decoration on a bow, which I believe is called a French eye, but I'm not sure because I just looked it up and I'm not really sure that I'm right, but I couldn't find the origin of it. But so far as I understand it, a French eye is a ring of metal, perhaps nickel or gold or silver, and then a piece of mother of pearl in the middle of it. And I don't have one to show you, but I'm sure that we can show you a photo of it over here or over there somewhere on the page so you can see what I'm talking about. Just fooling around with the idea of the French eye, First of all, I like to use it on the ends of my strap buttons. I think they look kind of cool. These are gold mother of pearl dots that are 2.35 millimeters diameter, and around them, I think you can see, is a piece of brass tubing, and this is a tubing that gets used in the shop more often than you'd think. Here it is. It's K&S Engineering, and these things are awfully useful. They make, as you can see on the package here, tubing, sheet metal, channel, angle, strip, and bar in small sizes for model makers and hobbyists. Here's two sizes. This is an 1/8 inch diameter, about 3 millimeters, and a 3/32 diameter tube. And I kind of considered both of these sizes for a decoration on the edge of the fingerboard. And I ended up thinking that it was, I don't know, I just didn't like it. It seemed a little fussy to me somehow, a little over the top. I decided to just go with one piece of pearl. But here it is with an ebony infill, and here it is with a mother of pearl infill. And while I'm holding this, I'll show you that you can see that the angle on this edge, there's an angle on this edge, it's not square. And I was using this piece of material years ago when I was trying to figure out how to get the right size drill so that the pearl, basically fit really closely and wasn't either hard to put in or slopping around in the hole, needing filler. So what I did was I made some cutters that I used as drills. So here's two drills that I made. This is a larger one. I can't remember what this one was for, but these are fine. They're single flute cutters that I ground by hand, and they're fine for making a shallow hole. The way we just need a hole that's maybe, I don't know, less than 2 millimeters deep anyway. Maybe 1.5 millimeters or 50 or 60 thousandths deep. Depends on how thick the inlay is, of course. I've been using these, which are, as I mentioned, they're gold mother of pearl, and it comes out to be about 3/32. These things worked okay, but I got a little frustrated. The reason I use this angled surface for a test piece is that when you set a regular twist drill down on an angled surface, of course, it wants to skate over and drill in the wrong place. In my opinion, the way these dots look as a group and the way it makes your work look is pretty important, that the accuracy is excellent. And this is something that is really difficult to achieve without a precise positioning device of some kind. It can either be a drill jig or, in my case, I use a milling machine to position them. That way I know they come out exactly where I want. Now you can see that I like to bias them towards the bottom of the fingerboard. It's just an aesthetic decision on my part instead of putting them in the center. So now I'm using a short drill that I was able to buy. Can't get them in every single size, but these were two sizes that I bought, and it turned out that the smaller one is just perfect. So this is a short drill, and I think this is solid carbide. Yeah, this is a carbide drill, and as you can see, the length of cut is only, oh gosh, less than 1/2 inch really. So there isn't a lot of drill to wiggle around. And using it in this way for this job, this will never need to be resharpened. It'll stay sharp forever and ever. Kind of good. And then this is so-called Luminlay, Luminlay. And this is kind of fun. I did this for a while. I don't know if I got disenchanted with it. I haven't done it for a while. These are glow-in-the-dark thingies. And so, yeah, I think you can see, you can so-called charge them up with some ultraviolet light. And then you can, you can get some energy out of them. They last quite a while. I think you can see that maybe you can, that they're lit up for quite a while in there. And turned out, I discovered that in order to get them to work well and last a reasonable time, you needed to drill quite a deep hole for these so that you could put a lot of material in there to take the charge. Of course, I can't pretend that I understand how these work. Maybe somebody can explain it to me. But I just thought they were kind of cool. And some of my customers like them. I'll still do it if somebody wants. But I sort of forgot about them until it came time to do this demonstration. Anyway, I think that's what I've got to show you here. Next, we're gonna move on to the milling machine and drill some holes. Pretty simple with a milling machine, not much to it. Easy peasy. If you were going to do it without a milling machine, I would suggest that perhaps the way to do it might be to make some kind of drill guide that would help you to get the drill in the right place here, and so that you could get the right dimension all along the neck. Get a handsome result, so that this distance between the dot and the bottom of the fingerboard looked like it was the same all the way along. I think that's kind of important for it to look professional and precise. Okay? All right, so now we're going to go to the milling machine and get it done. Okay, so here we are at the Bridgeport. So we're going to use this piece of material to clamp the neck in the milling machine vise. This is an interesting piece of kit. It's called Homosote, H-O-M-A, I think, S-O-T-E. And it's a kind of a cheap building material, like if you were building a chicken coop or something. I'm not sure where you would get it. I used to get it at lumber yards. And it's great because it's sort of like a hard-ish, softish cardboard that's got some compressible quality, and it's soft, though, so far as the things you're clamping is concerned. And it's pretty useful for things like this. So, as you can see, I put a cove cut in it on the table saw to kind of grab the back of the neck properly. And yeah, it makes that's a great way to clamp the neck. So, and then of course the next thing we'll need is to get the neck level with the travel, and we'll use this wonderful angle gauge here, set for 0. And then we see here, oh damn, we're pretty close. Oh gee whiz, we're pretty close. 0.2 of a degree. I guess we could do better than that. Let's see if we can. Oops. Let's start all over again. Okay. Start by eyeballing it level-ish. Oh, come on. I guess we'll have to take 0. Oh, that was lucky. Happens more times than you might think. Just to check. Okay. And then, you know, if we want, we could check with an indicator also, just to make sure we're not getting fooled by something. So, okay, so the indicator is showing us that this end of the neck is a little bit low. Oh, so nothing matter. So I guess that yeah, it might be worth trying to get a little better. So let's see. Showing that this end is high. Oh, I might have to move this end up. Oh, I think that's sitting on the right. So I'll have to move the low side up. Okay. Okay, so that's about 10 thousandths over 10 inches. Ain't much. But while we're here with the indicator, we'll see what we can do. Fussy little thing, of course, we wouldn't be bothering with it if it wasn't, right? Well, it's looking pretty quiet. A couple thou. We're not going to worry about that. Make sure we got it clamped nicely. Actually, depth is an issue because the dots aren't that thick. Like I said, they're only about 50 thousandths. So we need to locate the nut surface. So we can just eyeball this with a center finder. So we'll set our 0 and X and switch over to an 1/8 inch collet. And we're switching to an 1/8 inch collet because we'll get better concentricity with our drill than we would if we were holding it in the chuck. Although this chuck has been played with by me and actually is quite good, and nothing quite like a nice clean collet to get you right where you want to be. Okay, and so we're going to use this 09015 drill, and because I've been playing around with these things, I'm just checking to make sure it's the right drill. I haven't mixed things up. It's always good practice, actually. Check the drill size with the caliper for anything you're doing that's important. Okay. These are our numbers here for what I'm calling normal, which are the offset dots that I just told you that I like, where they're not laying in the center, but biased towards the fret that you're actually playing. Okay, so we'll pick up the first location here. And now we have to decide where we're going to put it in the y-axis. All right. So we're going to just have a look at that. Okay, that's what I want. And we'll call it 0. We're not going to move it. In fact, we'll give it a so-called lock. Now, we care about depth a lot because, as I mentioned, if here's the edge of the fretboard and the neck shape, and now we've got this drill coming down in this direction. So the depth of the drill will mean that it'll start cutting on the uphill side first, right? So it's this that we're concerned about. If we make the drill too deep, then the pearl can kind of fall in too far and get lost, and then there's a gap where you don't want it. So we have to make sure that we measure from the first touchdown point here, and so we don't want to exceed our part dimension from here to here, okay? And while we're at it, checking things, these are hard to keep track of. $52 thousandths or 1.3. Okay. So we're going to set a depth for the whole neck, and we can do that because we have, carefully with the indicator leveled this with the travel. Right now we need to pick up the depth as it cuts on the uphill part, the part of the fingerboard that's away from us, and 0 that, and then figure out how to drill that depth. Set that for 0, and I'm drilling now. To 50 thousandths, 49.5 it says. And so we'll just have a quick look at this, and sure enough, there it is where we want it. Okay. And now we're going to go ahead and we've set our stop, so we should get the same depth on all the holes, and we're going to go ahead and go to the next hole. Okay. That's it. That's the end of this. And I don't know if I really need to show you this, but I'm going to push the little things in the hole and touch them with crazy glue and sand them. But anyhow, there it is, all set. Ready for dots. Oh yeah, one thing is that with this gold pearl, there's a gold side and a not as gold side. So it's fun to try and figure out which side is golder. There it is. You can see, I think, that it's in the correct depth at the uphill side here. And just touch a crazy glue and we're done. All right, I think that's about it. That's all I know. Hope this helps. Take care, everybody.